Hey everybody, in this video we are looking at example 7. This is finding a projectile height. This is a word problem with projectiles, which we saw in previous lessons, and it's also going to be in our current unit on inequalities. So this is basically going to, if you can use context clues here, basically ask us when will this object be at least this high, or when will this object be no more than this high above the ground, okay? So just as a recap, the equation we use for projectiles is S, or sometimes S of t, for position, equals, when we're dealing with free-falling objects on Earth with the acceleration due to gravity of Earth, they'll always start with negative 16 t squared plus v sub 0 t, meaning the initial velocity, plus s sub 0, meaning the initial height. In this situation, our initial height is 0 seemingly, and our initial velocity is 96 feet per second. So we can deduce, pull all that information out from the equation before we even start reading, but let's get into it. If a projectile is launched from ground level, there it is, with an initial velocity of 96 feet per second, its height s in feet t seconds after launching is given by the following equation. S equals negative 16t squared plus 96t. Really, you should be able to write that equation yourself. However, it's given. When will the projectile be greater than 80 feet above ground level? All right, so what is the height of the projectile? The height of the projectile is literally equal to this. The height of the projectile is equal to negative 16 times squared plus 96 times time. So that right there represents the height of the projectile. So I'm going to write that down over here. Negative 16t squared plus 96t. And I want to know, when will it be greater than 80 feet above the ground? So when will it be greater than 80? In order to get this going, I'm going to bring over the 80 just so I have 0 on the right. But then I'm going to divide by negative 16. And like we spoke about in an earlier example, when you divide both sides of an inequality by a negative, you have to flip your inequality sign. So let's see what we got here. We have negative 16t squared plus 96t minus 80 greater than 0. We're going to divide everyone by negative 16 because I can tell that everything will be divisible by negative 16. For instance, I know that 8 times 10 is 80. Right? In my head, I'm already thinking about this. If I double the 8, I have 16. If I cut the 10 in half, I have 5. That means 16 times 5 is also 80. So I know 16 goes into 80. But then I know 80 plus 16, I could see that that is 96. So that means it's also divisible by 16. In fact, that means it'll be 16 times 6, and 16 times 5 is 80. So we got all that going on. So let's divide by the negative 16. We get positive t squared minus 6t plus 5. And now, got to flip the sign. Don't forget that. It's going to be less than 0. Now, we're going to factor. And as we've discussed many times, when we're factoring, sure, I'm going to keep the inequality sign because I'm still trying to answer the question, when is the quadratic on the left of this inequality going to be less than or below 0, or below the x-axis, essentially. We always got to get it equal to 0 before we can factor. You can't factor and solve until you get it equal to 0, okay? So we have t squared, so that means we have t and t. 5 is prime, so we only have 5 and 1. Negative 6, so they're both negative. Set each of those equal to 0, not less than, greater than, none of that. We set each of those equal to 0. I don't know why I wrote it like that. Set each of those equal to 0. So what do we end up getting? T minus 1 equals 0, so t equals 1. T minus 5 equals 0, so t equals 5, right? We set each equal to 0, we solve for t. Now, let's zoom out. Okay, that found for us our x-intercepts. Actually, I don't need to draw it really that high up, so let's be more reasonable here. So I have my x-axis, and then here's my y-axis, or really s. Oh, that's too smudgy. S-axis right here, and this over here is t. Okay, Now, the object, we saw it started on the ground. Over time, it went up. The height increased over time, and then it comes back down, and it'll inevitably, due to gravity, land on the ground again at some point, right? So the red is showing us the path of the projectile, not the path, but the height of the projectile, rather, literally over time. Now, 80, well, it's going to be the time, the height that I'm curious about, right? When will this projectile be greater than 80? So visually, when does that happen? When is the red graph above that blue graph right there? So what will my answer be? It's going to be from this value until this value. And based on my solving, that's 1 to 5. Now we could actually deduce a little bit more information here if we needed to know. Since it took 1 second to get to 80 feet, it's going to take 1 second to go from 80 down to 0. So that is 0, and that makes this one 6. Also, since parabolas are symmetric, that means what's the midpoint of either 1 and 5 or 0 and 6? Midpoint, midpoint. What do? Add them together and divide by 2. 0 plus 6 divided by 2, 3. So that means it'll take 3 seconds to reach the maximum height. These are just some things that we can deduce, right? Now, based on this, I know my answer will be between 1 and 5 seconds. Or maybe we think of it as on the interval 1 to 5. Right? But if I were just looking at it as solving over here, right? So let's just go back to this. So if I were just solving this straight up algebraically, not thinking too much into this, that means that the thing we're solving, once we got it with the 0 and with the factoring, we're looking really at that line. So here represents my x-axis. My x-intercepts are 1 and 5. This particular quadratic is opening upward, and it has those two x-intercepts. Like mentioned in the other examples, since this and this are both to the first power, that means that each x-intercept behaves like a first degree or a first power, which is linear, so we slice straight through over there. And I want to know when is it less than 0, so I want to know when is it below the x-axis, and that's going to be from 1, yikes, why does it keep doing that? 1 until 5 seconds. So either way, we're going to get the same answer. It's just a matter of how you are interpreting your information and when you're able to come to your conclusions. So I hope that was helpful. I hope you understand. Any questions or comments, please, by all means, leave them for me in the comment section. Check the playlist. There's 2 on the screen. Find the one that is best for you. And that's it for now. Adios.